Let's begin section 3.2 with a little review of terminology. Recall we said the vertex of the parabola is its maximum or minimum point. Every parabola has a vertical line of symmetry which passes through the vertex. Recall we said this line is called the axis of symmetry. And lastly, the zeros of a parabola are the x-intercepts. These are the places where the function equals 0. We're going to spend some time in this particular section looking at the formula for a quadratic or of a parabola in what's called vertex form. So first of all, we need to know the formula that would be called vertex form. So a quadratic that's written in the form y equals a multiplied by the quantity x minus h squared plus k is said to be in vertex form. When our quadratic is in vertex form, the vertex of the parabola is hk, and the axis of symmetry is x equals h. And it's important, remember, to use x equals because it is actually an equation when we are talking about the axis of symmetry. So it will be important to us that we make sure that we write a full vertical equation. The parabola will open up if a is greater than 0, and it opens down if a is less than 0. Before I move on, let's just take a look at a couple of graphs. So suppose I had a parabola that looks something like this. Okay, here would be our vertex, and so that would be h comma k. And the axis of symmetry would be the vertical line which cuts through the vertex, and its formula would be x equals h. This is a parabola where a is greater than 0. If I actually had a parabola that opens down, again, I'd have my vertex, hk. Again, my axis of symmetry would be x equals h. It would again be a vertical line that passes through the vertex. And in this case, though, my a would be less than 0. The parabola is concave down. It opens down. Let's take a look at a couple of examples. Suppose I have the function f at x equals 4 multiplied by the quantity x minus 1 squared plus 7. Using what I noticed with my formula, I would notice my vertex has an x-coordinate of 1, so that's my h, and a y-coordinate of 7, that's my k. Notice with the h, it's the number that follows a negative, and with the k, it is the entire signed term, so in this case plus 7. So the vertex is 1, 7. The axis of symmetry is always x equals h, so it's x equals 1. Let's take a look at a second example. F at x is negative the quantity x plus 5 squared minus 1. So my vertex here would be negative 5. Remember that my h is what follows the negative. So it would have to be x minus a negative 5. So my vertex would have to have an x-coordinate of negative 5. And then the k is the entire term, including the sign. And so that's negative 1. Using the same principles we did before, the axis of symmetry would be x equals negative 5. Notice our a here. A would be negative 1, which means this parabola opens down. I didn't do this with the previous example, but I could do it with this one, where I could actually graph some information. I know that my vertex is at negative 5, negative 1, and I know the parabola opens down. So I could actually draw a quick graph of the function.